to everyone. We want to present our article, Method of Multipurpose Text Analysis based on a combination of knowledge bases for intelligent chatbot. The main goal of text message recognition for chatbot is adequate level of text recognition, conducting a complete semantic analysis with the identification of the information context. Also, it is a self-study based on previously received information for better performance and the ability to introduce the analysis of several subject areas. The relevance in the information sphere this topic is very actual and can be used in daily social media posts to detect spam and screening spam messages, mobile applications, and in the last time is related to online dominant instead of offline meetings, so it's too important. Text recognition issues is that semantic analysis and anomalous situations that occurred is related to text messaging when user enters some bad information, bad data, or avoid some word combinations, but we need to check this data also and don't forget about it. Also, it is incorrect user message and data for analysis needs to be divisible to better performance for the next using by the systems. So solutions which are provided to resolve the issues is to use filter based on frequency for avoid nonsense text constructions like and or something else, or also integral memory for checking user data before main analysis. This relates to avoid some situations when we check information which is not relevant for us, and also the cases when we can take some phrases as in the other meaning. And also it's a separate analysis for each terminology database which presented by a distributed shared database which can be divided for different topics or sub-levels of our subject area. Also, we can use global search like services from Google or Bing for increased performance because we don't have enough possibility to use to talk about everything, so we need to analyze only our topic. But in case when we don't understand what user meaning, we need to use some other places to get information from. So we decided to use search services. Also, it's increased number of knowledge bases for better understanding. Also, we provided in this article different tests related to this with using 2, 3, and 4 knowledge bases and with their analysis and performance by time using for each knowledge bases to analyze. And also it's a create terminology preferences in dialog session, including priority of received results. This needs to avoid situations when some result from terminology database is not correct for us, and we need to restrict some data, and this will help us. So, and also terminology database need to be divisible on small blocks. In our case, we decided to use sub-levels of terminology database related to subject area, and also combining 26 tables for each letter of English alphabet. But if we can add more languages, we need to add only the number of tables which presented the number of letters in alphabet of language that we need to use. For intellectual part, we use recurrent neural network with using method long short-term memory, which presented as a simple. Each block of this neural network is presented as simple neural network with forget gate and which can memory about which can save information about the entrance, and then on output we receive the data, and this is a simple way to use in our topic. So the next is combination of LSTM with recurrent deep neural network is increasing of the quality for learning rate. Also it's a scalability of nodes and simplification of architecture, resistance to time gaps because text length can be different from time to time, and also variable length of incoming messages, possibility of reverse propagations. On this slide you will see architecture of applied implementation, which relates service, web service. On server side of which we use .NET platform and ECMAScript. Also, it's combined in Docker, and we can host it in the cloud. Also, we used Google custom search API, which presented by this, as you see. After that, this is a model of user experience. So user entered some information, then we converted it by semantic text analysis to simple combinations of words, and then transfer data component will be send information to terminology databases, and after that we received information from the terminology database with keywords set for each terminology database, and after that we checked the result. If we find that some of our database returns correct data, which approve our threshold, after that we return the data. But if not, we can use Google search, and in this case we increase the chance to get the correct data, and after that we return the data. In this case we used Google search, but for our tests usually we use information from our databases. So the structure, as I said, presented by 3 topics. For example, it's related to physics. We don't use it, but the structure is the same for all subject areas which you want. So in this case we have 26 tables for each database, and in this case the total set of our physics terminology database will contain 3 sublevels of shared distributed databases related mechanics, quantum mechanics and biophysics, and in this case that's enough for getting enough information about one of these 3 topics from the physics subject area. So about the testing of our implementation, on this table you will see the average times, found times per text. So for this we used several data sets related to car, history, banking and business, and also in this case we select average processing time, the number of terms which we found also, and the correctness level which presented as the total number of terms which we have and terms that we found. So in this case the correctness level, as you see, is up to 89, or no, not 84 and 7%, and that's enough, I think. Also we have a comparison between different methods for text analysis. Also in our article paper you will find information about using 2 and 3 also subject terminology databases, and the result will be some different, but in the same key. So as you see now, it's a comparison between using different methods for text analysis, and as you see, the using for subject areas is better than others by correctness level, and also by found phantoms, which presented in our article. Also, but the average processing time is the most expensive, but in case of correctness I think that it is better to use it, because we need to know what user want to say more than the time that we waste for it. So in this case, this is enough, I think. Thanks for presentation.